Hello, my dear students. Today we are going to learn similar triangles and criteria of similarity of triangle. Okay, so we have to understand the meaning when we can say two triangles are similar. In class 9, we did congruency of two triangles and its criteria. Here we'll learn similarity of triangles. So if two triangles are similar, then their corresponding angles will be equal and the ratio of sides of corresponding sides are equal, right? So through animated video first we'll try to understand. Okay, just observe it.
Now let's try and get a deeper understanding of similar triangles. Consider two similar triangles, triangle ABC and triangle PQR. Vertices ABC correspond to vertices PQR. Okay, these triangles are similar, but what else do similar triangles convey? What do they tell us about the sides and the angles? Well, quite a lot, I would say. First, let's look at the sides. Similar triangles always have their corresponding sides in proportion. In these two triangles, based on the correspondence, side AB corresponds to side PQ, AB and PQ. Similarly, side BC corresponds to side QR and side CA corresponds to side RP. Corresponding sides in proportion means the ratio of all three pairs of corresponding sides will be equal. The ratio of AB to PQ will equal the ratio of BC to QR will equal the ratio of CA to RP. AB and PQ are corresponding sides, BC and QR are corresponding sides, and CA and RP are also corresponding sides. But what does this actually mean? It means that each side is scaled up or scaled down by the same factor. Here, factor with which AB is increased to get PQ is the same as the factor with which BC is increased to get QR or as the factor with which CA is increased to get RP. So remember, when the triangles are similar, the corresponding sides will always be in proportion. Now let's get to the angles. Similar triangles always have the same shape. What does that tell us about the angles? Yes, the measures of corresponding angles of similar triangles will be equal. Based on the correspondence of vertices, angle A corresponds to angle P, angle B corresponds to angle Q, and angle C corresponds to angle R. So angle A will be congruent to angle P. This can also be written as measure of angle A is equal to measure of angle P. It means if we take a protractor and measure these two angles, they will be equal. Similarly, angle B will be congruent to angle Q and angle C will be congruent to angle R. When the triangles are similar, their corresponding angles will be equal. So we can deduce all this when we are given that two triangles are similar. Here we were given that triangle ABC is similar to triangle PQR. Is similar to can be replaced with this sign. So this can be read as triangle ABC is similar to triangle PQR. Actually, it also works the other way around. If we were given either of these conditions, we can say that the triangles are similar. Remember, either of the conditions. So if we are told that all pairs of corresponding sides are in proportion, we can be sure that the triangles are similar. Or even if we were told that the corresponding angles are equal, we can be sure that the triangles are similar.
So from video we understood when we can say two triangles are similar. If two triangles are similar, then what things we can write? Number one, corresponding angles should be equal, and number two, ratio of their sides will be equal, right? Now theorem 6.3 we try to understand. If in two triangle corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar. Its proof is not in syllabus, so only we have to understand the meaning of it. This is called a a a similarity, right? Similarity. So according to it, it will take two triangles. Suppose this is a triangle and one more triangle I am taking, and this is another triangle, right? So this is ABC and this is PQR. So if angle A equals to angle B, angle B equals to angle Q, angle C equals to angle R, then we can say that triangle ABC similar to triangle PQR. I hope you understood, right? So here three angles, always no need to prove equal. If we'll prove only two angles, automatically third angle will be equal. So this is called AA similarity. So here I am showing to you, in place of AAA similarity, if we take two triangles, this is one triangle, take another triangle, okay, so one more triangle I am taking. Suppose this is second triangle, A B C P Q R. Okay, if angle A equals to angle P and angle B equals to angle Q, third angle no need to show, they are equal. Okay, so we can say that triangle ABC similar to triangle PQR, and this is called AA similarity. So give heading AA similarity. Okay, now next property. Okay, if in two triangles side of one triangle is proportional to the side of the other triangle, then their corresponding angle are equal, and hence the two triangles are similar. That is called SAS congruency. So take one triangle, now take another triangle, so take another triangle, this is A B C P Q R. So here suppose angle B equals to angle Q, and AB by PQ, if AB by PQ equals to BC by QR, and angle between these two sides will be angle B equals to angle Q. Then we can say that triangle ABC similar to triangle PQR, and this is called SAS similarity. Okay, right? Side, angle, side. Now next concept, if one angle of a triangle is equal to one angle of other triangle and the side including these angle are proportional, then the two triangles are similar. So if in two triangles side of one triangle is proportional to the side of other triangle, then their corresponding angles are equal and hence the two triangles are similar. So okay, so theorem 6.4, if in two triangles sides of one triangle are proportional to the side of other triangle. What is the meaning of that? Take two triangle, they take one triangle and take one more triangle. So this is A, B, C. This is P, Q, R. So here, according to this theorem, AB by PQ equals to BC by QR equals to AC by PR. Right? Then we can say that triangle ABC similar to triangle PQR, right? And this is called SSS similarity. Okay, now next, if one angle of a triangle is equal to one angle of other triangle and the side including this angle are proportional, then the two triangles are similar. So take one triangle, then take another triangle. Now this is A, B, C, P, Q, R. So here suppose angle B equals to angle Q, and these two angles, we have taken these two angles. So one angle of a triangle is equal to one angle of other triangle and the side including these angle. So side including this angle will be AB by PQ equals to BC by QR. Then we can say that triangle ABC similar to triangle PQR, and this criteria is called side angle side similarity. So we are getting here three criteria. Number one, AA similarity, most of the time we'll use AA similarity in 90% questions. Okay, we have to use AA similarity. Then SSS, that means all three sides are in proportion. SAS, that means side, angle, side. Okay, so one angle of both the triangles should be equal, and side including these angles, okay, are proportion. Then we can say that two triangles are similar. And if two triangles are similar, then we can say all corresponding angles are equal and ratio of their sides also equal. This was the concept in 6.3. Now we'll start question. So just check question number 2 of exercise 6.3. In figure 6.35, triangle ODC and BOA are similar. Angle BOC equals to 125, it is given. Angle CDO equals to 70 degree, it is given. So we have to find angle DOC, DCO and OAB. So first write given triangle ODC similar to triangle OBA. Angle BOC equals to 125 degree and angle CDO equals to 70 degree to find. So we have to find angle DOC, angle DCO and angle OAB. So understood question? So in questions, what is they are asking? First of all, though, ODC and OBA, these two triangles are similar. Angle BOC 125, this is given. Angle CDO 70 degree, this is given. So we have to find DOC. So its solution. So if you want to find DOC plus 125, these two angles are linear pair. So sum of these two angles will be 180 degree by linear pair axiom. So from here angle DOC can be written 180 degree minus 125 degree. Now subtract. DOC equals to, you will subtract here 5 and 7 minus 2, 5. So 55 degree. Right. So understood? Now next is DCO. If you want to find DCO, this angle we have to find. Now this angle and OAB, they are equal by CPST, right? So angle DCO equals to DCO, we have to find DCO, na? This angle, if you want to find So angle sum property will use, it is better. Angle sum property, here this is a triangle, ODC is a triangle, sum of three angle of a triangle will be 180 degree. So from 180 we'll subtract 70 degree, and this angle is 55 plus 55 degree by angle ASA, angle sum property, ASP, angle sum property. So what we are getting, 180 degree minus 125 degree. So here also we are getting 55 degree. Now last OAB, OAB we have to find. Since triangle ODC, ODC and OBA are equal, then corresponding point of C is A. So we can say that angle DCO equals to angle OAB. Logic will be CPST. Right? You will not make mistake. These two angles are not alternate interior angles. From CPST we can say that they are equal. So DCO already we got 55 degree. So angle OAB also will be 55 degree. So angle OAB equals to 55 degree. So we got all the angles. Now next question, come to the next question. Question number 4. In figure 6.36, QR by QS equals to QT by PR and angle 1 equals to angle 2. So first write what is given. So first write given is QR by QS equals to QT upon PR and angle 1 equals to angle 2. To prove triangle PQS similar to triangle TQR. Right? Now proof. Here angle 1 equals to angle 2, so we can say that PQ equals to PR from property of isosceles triangle. Since angle 1 equals to angle 2, so we can say that PQ equals to PR. Opposite sides of equal angles. Opposite sides of equal angles. Right? Now here here PQ equals to PR. PQ equals to PR. Right? Now in place of PR we can write PQ. Therefore QR by QS equals to QT by PQ. Now we have to prove PQS and TQR are similar. If you take its reciprocal, both sides take reciprocal, QS equals to QR equals to PQ upon QT. So QS upon QR equals to PQ upon QT, and this is common. So what we can say that PQS and TQR both are equal. Now angle 1 equals to angle 1. It is common. Therefore, triangle PQS similar to triangle TQR by SAS. I hope everyone understood. Here only one concept you have to use. Angle 1 equals to angle 2. So we can write PQ equals to PR, and this PQ equals to, in place of PR we'll put here PQ, take a reciprocal, and angle 1 is common. So by SAS criteria we can say these two triangles are similar. Now question number 6. So if you'll see your book, just open and see this figure 6.3. 6.37. So I'm drawing this So draw this figure. A, B, C. Here take 2 points. This is D and this is E. Join B, join CD and join D. Now in this figure, triangle ABE congruent to ACD. These two triangles are congruent, it is given. We have to show that ADE, triangle ADE and ABC are similar. So what is given here? Triangle ABE congruent to triangle ACD. To prove. Now what we have to prove? Triangle ADE similar to triangle ABC. Now proof part. So how you can prove these two triangles ADE and ABC? First of all, we can observe angle A is common. Only side we have to prove equal. Since triangle ABE congruent to triangle ACD. So what we can say? AB equals to AC and one more things, AE equals to AD. This is from CP CT, right? So from CPCT we can say that these two things are equal. AB equals to AC and A equals to AD. It means if we'll consider ADE, then AD by AB. So therefore AD by AB equals to AD equals to AE and AB equals to AC, and angle between them, angle A equals to angle A. So we can say by SAS criteria, triangle ADE similar to triangle ABC. So I hope you understood this, right? Just check properly, write down first. Now next question. Draw a triangle A, B, C and AD is perpendicular to BC and C is perpendicular to CE is perpendicular to AB. So this is also perpendicular and this is also perpendicular. Okay. So this will not consider, this figure not for these questions, so remove it. So this part I am removing. Now what is given? AD perpendicular to BC, right? C perpendicular to AB. Now to prove, number one, triangle AEP similar to triangle CDP. Number two, triangle ABD similar to triangle CB. Third, triangle AEP similar to triangle ADB. And fourth, triangle PDC similar to triangle BC. Now proof. For first, AE are here P. AEP and CDP. Okay, AEP and CDP. In these two triangles, what things are equal? Just check. Angle E equals to angle D. Why? Both are 90 degree. And angle APE equals to angle APE equals to angle CPD. Angle CPD, vertically opposite angles. Therefore, triangle AEP similar to triangle CDP by AA similarity. Now number 2, ADB, triangle ABD, similar to triangle CBE. That means ABD. So here clearly angle D equals to angle E. Angle D equals to angle E. Why? Both are 90 degree. Right? And one more angle is required. Angle B is common. Angle B here also, here also. So angle B equals to angle B. Why? Common. So we can say that very easy. Triangle ABD similar to triangle CBE, here also by AA similarity. Now third, AEP and ADB, AEP. So here angle E equals to angle D. First of all, so this is in every answer we have written E and D are equal because both are 90 degree. Both are 90 degree. Okay. And one more angle we need, AEP and ADB. So angle A will be common. Angle A equals to angle A, which is common for both. Therefore, triangle AEP similar to triangle ADB by AA similarity. Now fourth part. Fourth and last part, PDC similar to BEC. So first of all, angle D equals to angle E. Both are 90 degree, and PDC and BEC. So PDC this angle, and BEC this angle. So angle C will be common. This angle is common. So angle C equals to angle C common. Therefore, triangle PDC similar to triangle PDC and BEC. So its figure is 6.39. So question number 9. So first we'll draw this figure. So this is A, this is B, this is P, this is M, and this is C. This angle and this angle are 90 degree. Now, what is given here? ABC and AMP are two right triangles, right angle at B and M respectively. So it means A, B, C and A, M, P are two right triangles, right? Now to prove. So we have to prove number 1, triangle ABC similar to triangle AMP, and number 2, CA by PA equals to BC by MP. So understood? Now it's proof part. Okay. So first one we prove ABC and AMP. So it is very easy. Angle B equals to angle M, both are 90 degree. Angle A equals to angle A. Why? Common. So by A criteria, we can say that triangle ABC similar to triangle AMP by AA similarity. If these two are similar, then we know that CA by PA, CA by PA equals to BC, BC by MP, BC by MP, CPST.